So in this video, we're going to be talking about the difference between a population and a sample when we're doing statistical studies. So we'll start by defining both of these. A population is the entire set of subjects in which there is an interest. So the actual people, or might not be people, might be things that you're investigating something for. A sample is a part of the population, so that's key. It's not the whole thing. From which your information or data is gathered, often for the purpose of generalizing from the sample. So you want to find something about the population, but it's a lot easier to take a smaller sample of people, or again, things, to find out something that you can generalize. So here is an example. In the United States, a survey of 2,184 adults ages 18 and over found that 1,328 of them own at least one pet. Okay, well, what's the population? They wanted to know something about adults in the United States. That's your population. But they didn't necessarily ask every single person in the United States. The sample would be those 1,328 of them that got back to the people who were doing the survey. So the sample here, if this is our population, the sample would be the 1,328 who responded. So the population is usually very general, and the sample is usually a little bit more obvious based on what we actually know from a survey or from some kind of study. So this is the sample. Okay. So here are a couple more examples where we're going to read through it and we're going to identify the population and the sample, kind of like what we just did. So part A says to estimate the gasoline mileage of new cars sold in the U.S., a consumer advocacy group tests 845 new cars and finds they have an average of 25.1 miles per gallon. Okay, so the population of interest here, they wanted to know something about the gasoline mileage of new cars sold in the U.S. So we can simplify this a little bit. Our population would be new cars sold in the U.S. Now, obviously, that would be really difficult to take a look at every single one that's sold. So this group instead tested 845 new cars. And so that is our sample. That's who they found something out about. And then generalized it about all new cars. Okay, part B says a survey of 4,464 shoppers in the U.S. found that they spent an average of $407.02 from Thursday through Sunday during a recent Thanksgiving holiday. Okay, so it sounds like the survey was trying to find out something about shoppers in the U.S. That would be our population. And our sample, it sounds like from their survey, they got responses from 4,464 shoppers. So those people make up the sample. So you're noticing probably that a lot of times our sample has a number in it because there's a specific number of people or things that were used for to generate the sample. So now I want to talk about what it means for a sample to be representative. So if you take a sample for the purpose of generalizing to a population, remember that's always really the intention, then the sample that you choose really should then be representative of the population. You want to choose people that would be a good sample for what you're trying to find out. So it must be similar to the population even though it's smaller. That's really key. So there's really no procedure that guarantees this, but the best thing that you can do is choose a sample where every different possible sample has an equal chance of being chosen. And that would only come if you're doing a random sample. So everyone who could potentially be in the sample has an equal chance of being chosen and therefore an equal chance of representing the population. So here's an example. It says, suppose you are the campaign manager for your friend who's running for senior class president. You would like to know what proportion of students would vote for her if the election was held today. The class is too big to ask everybody. There's 314 students. So what could you do? So here are a couple of ideas, and we'll talk about whether or not these would be representative of the population that's intended. So this first one says you could poll everyone in your friend's math class. Okay, so you might get, 25 responses or so, but you're only getting the people in your friend's class, and they might be biased because they might know your friend. So I don't know that this would be the best way. So we could say something like not representative. This isn't random at all. Plus, all of those people know your friend in some capacity because they're in their class. So they know the person running. And again, it's not random. Okay, the second one says, assign every student in the senior class a number from 1 to 314, then use a random number generator to select 30 students to poll. Okay, well, this really and truly would be random. You're not going off of anything about the people that are being chosen. You're keeping it completely random. So this would be a good way to do it. So that random piece is key. Then the third one says, ask every student who is going through the lunch line in the cafeteria who they will vote for. Okay, this is probably more representative than just people in your friend's class, but still you're only asking the people that are buying lunch, which isn't necessarily going to represent everybody in the school. So while this might be a little bit better than part F, I still don't think this is a great way. So this isn't totally random, while it's more random than asking people in a class. So that one might be somewhere in the middle, but I still think G would be the best way to go about this. Okay, so now I want to talk about the numbers that we actually get from either a population or a sample. So a statistical study begins with a question of interest that can be answered by data. So depending on the study, data could be collected from all individuals in the population or from a random sample, depending on convenience. So what is a population characteristic? This would be some summary measure that's calculated using all the individuals in the population. And we call that a population characteristic. It's also sometimes called a parameter. So for example, this might be a population proportion or a population mean. So what that means is if I wanted to find out something about everybody in the school and I asked them and then I averaged all of the answers, then I would be getting the population mean because I found the number from every single person. A sample statistic is also a summary measure, but it's calculating using data from a random sample. So if it's not calculated with everybody, then it's called a sample statistic. So it kind of makes sense. You have some alliteration here. Population, you can call it a characteristic or a parameter. They both start with P. And for a sample, we call it a statistic. So when you hear people talking every day about statistics, those are numbers that are not pulled using every single person involved. There's usually a sample that was chosen, whether it was through a survey or something like that. So this could be a sample proportion or a sample mean. So again, if you're trying to find out some quantity from people in your school and you just ask a sample of them and average those numbers, then you have a sample mean and not a population mean. So a sample statistic meaning not a value from every single person is considered. Okay, so this is saying we're going to let the population of interest for every example that follows be the words of the Gettysburg Address. So all the words in the entire address that Lincoln gave, and there are about 269 of them. It does say depending on the version that you read. So again, population, words of the Gettysburg Address. So we're going to read through each of these and identify which of the summary measures represents a population characteristic, or again, we could say a population parameter, and which one represents a sample statistic. And then we'll have to explain briefly. So this says the proportion of nouns in all words of the Gettysburg Address. So you'd be looking at every single one of those 269 words and finding the proportion of them that are nouns. Well, this is a population characteristic because you're using all of the words. So really key here is that they say all words. That makes it a population characteristic. The proportion of nouns or the proportion of words containing the letter E in a random sample of words taken from the Gettysburg Address. So you're still finding either a proportion of nouns or words with E, but you're doing it from a random sample. That's the key. So we would call this a sample statistic. Okay, this is the mean length of the words in a random sample of words taken from the Gettysburg Address. So we're finding a mean, so this is definitely some calculation, but it's from a random sample. So again, sample statistic. The proportion of all words in the Gettysburg Address that contain the letter E. Okay, key words here. Proportion of all words. That means that this is a population characteristic. And finally, the mean length of all words in the Gettysburg Address. There it is again. All words. This is, again, a population characteristic. So really, in summary, a statistic or a characteristic, it's just some measurement from your data, but it just depends on, did you take it from every single person or every single quantity involved, or just from the ones from your sample.